In this final video on capital budgeting techniques, we're going to start by looking at modified internal rate of return. We're going to also talk about profitability index. And we'll try to pull everything together and do what are the problems, when does this work, when does it not work, and what can we say about the basics of capital budgeting. We're going to start by saying we just threw a whole bunch of stones at internal rate of return. What if we just tweaked it a little bit so that we could get something out that didn't have all the problems? Somebody came up with a great solution, and honestly I have no idea who this was. I've chased it down once before, and it was a couple of people who presented this as a possible solution in one of those journals, not so highly respected in the industry, and yet this result has hit virtually every textbook. It's called modified internal rate of return, and this has had a greater impact, in my opinion, on the practice of finance in business than some of the big ideas that have hit the Journal of Finance types of academic journals. Modified internal rate of return is an attempt to fix the problems that IRR had. In particular, once we go through modified internal rate of return, there is only one. You can't get two or three. You can only get one. We specifically reinvest at weighted average cost of capital, not at the IRR rate. And we force all of these solutions, but we still get something that is telling me what kind of a, quote, I'm doing my fingers again, return on investment we've got, okay? So, MIRR can be seen as a more realistic return on invested capital. And I'm going to also point out that it is such a great solution that even though I'm going to show you how to do this on a regular calculator, and you're going to have to follow about a whole bunch of bizarre steps, you don't have to if you're using Excel, because Excel has MIRR built in. That's how important and how great a solution this turned out to be. So the steps that we're going to follow, if you don't have a calculator that does this, and some of the newer calculators actually do an MIRR for you, would look like this, and I want to go through them anyway just so you know what it's doing. So the steps are these. First, create the cash flow timeline. Yeah, again. Then we're going to sum the present value of all cash outlays. In other words, we're going to get them all to present value. If we have a conventional cash flow stream, then all of them will bring to present value. Even if we have a non-conventional cash flow stream, we're going to get all of our outlays in present value. And then we're going to move all of the cash inflows to the last time period. We're going to do future value for all of those. So we've now parted the outflows and the inflows about as far as we can. We're sort of like parting the Red Sea kind of thing, okay? And then what we do at that point is we take the present value as my investment. That's the stuff from step 2. And we take the stuff from step 3, that future value, as my outcome. I have no payments in the middle because I've just moved them to one side or the other. And then we just say, what is the interest rate that bespeaks? By the way, we move things in steps 2 and 3. We move them specifically using the weighted average cost of capital. That way we're making sure that we're reinvesting at the weighted average cost of capital throughout. Again, I'm going to do the same old example. Your chief financial officer of Spamway, blah, 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 blah. Project Gamma, Project Psi. We're going to do steps 1 and 2. It'll look like this. We have my cash flows in a timeline, and all of my outflows are already in times 0, so I don't have to do anything, okay? Then step 3, I'm going to move all of my inflows to time 5, which is my final time period. So I'm going to take that one and move it once at 9%. And it's going to be more. It's going to be worth more in time 5 because I'm earning 9% on it. 470 is going to be worth more because I earned 9% on it compounded twice. And so on and so on. Notice I don't do anything with the time 0 stuff because it's, well, negative. And I have to move it to time 0, which was step 2. So I'm going to sum all this stuff, and I get the $2,802.53. And then I'm going to move it up to the top, so they just have the 2. This is the same amount, 2802.53, and negative 1,500. At which point I say, what kind of a rate, interest rate, would that be? 1,500 investment, 2802.53 at time 5, no payments in between. Answer, 1332%. Now let's take a look at the other example. This one is Project Psi. With Project Psi, we're looking at 3,000 and then all those other inflows. So we've created our cash flow timeline. We have 3,000 in time 0 already, so we don't have to take the present value of any other negatives. So we're all ready to go, and we move on to step 3. Step 3, we're going to take the future value of all of the inflows. So I'm going to, 1150 is already in time 5, 1054 is moved up there by allowing it to grow at 9%. Then 955 grows at 9% for 2 periods. Then 855 grows at 9% per period for 3 periods, and so on. We add them up, they are 5,606.49. I move that my 5606.49 up to the top so that it's right under my 50606.49, and then I just say, what interest rate will that be? To invest 3,000 at time 0, end up with 5606.49 with no payments, because I've taken into account all my payments in that year 5 by moving them up there. And the answer, 1332%. Yes, they're exactly the same. So let me show you how to do MIRR in Excel. MIRR. The MIRR is equal to MIRR, yeah, you guessed it. And in this instance, we're going to grab our numbers, great, and we're going to include cash flows at time 0. Then we put comma, and it asks for our financing rate. Oh my word, it says financing rate and reinvestment rate. Oh no. Ooh. Now the financing rate is our weighted average cost of capital for sure. So we hit that one, and because I'm going to copy this one over, I'm going to hit my F4 key. Then I hit my comma, and it says reinvestment rate. This is just in case we wanted to use a different reinvestment rate. But I'm not going to reinvest for anything less than weighted average cost of capital. I may be able to invest at a little more. This allows me a little bit of flexibility where I can actually allow for an reinvestment rate that's a little higher than my weighted average cost of capital. In this instance, because of the way we're setting this up, I'm just going to use the exact same numbers, and which we can do, by the way, so don't stress. Whoops. And I'm going to hit my F4 key and close my parentheses and hit enter. Let me move this one out. It should be 1332. Oh, look, it is. I'm going to copy across. Oh, that one is too. They happen to be exactly the same, although they're not. If you actually go out a few more decimal points, you'll find out that they're not exactly the same. So another way of looking at this, by the way, and I'll come back to MIRR in a minute. So another way of looking at net present value and trying to figure out what in the world it's doing and whether I should invest in project A or B or S or L or whatever the two are is looking at how the net present value changes given the discount rate. This goes back to the I'm not absolutely certain as to what my weighted average cost of capital is, especially adjusted for the risk on this project. If I'm just a little off, does it change which of the two that I would invest in? If I can invest in one and not the other, if they're mutually exclusive. Since the discount rate should be sensitive to changes in project risk, net present value profiles will show how sensitive the project NPV is to the appropriate discount rate. What the profile does is it graphs them. So along the x-axis we're changing the discount rate, and along the y-axis we're showing the net present value. And if we have two or three of these, especially if they're mutually exclusive, in other words I can only invest in one of them, then it looks something like this. We end up with a project L. By the way, this is from I think an older textbook, and I plugged all of this stuff in. The project L is a long term, a lot of it comes out longer term, and S is shorter term payback. But you can see that they cross over here at rate 8.1%, which is really close to the one in our book too, by the way. And so we're saying they are both positive at that point, but if I had to rank them, as long as they're above 8.1%, I would choose project L. If they're below 8.1%, actually I did that wrong, didn't I? If they're above 8.1%, that's along the x-axis, I would be more interested in investing in project S. And I should also mention that as long as it is above the zero line, because out at about, what is that, about 13-ish, 13.5%, probably don't want to invest in either one. If the discount rate's below 8.1%, then I'm going to go in toward the left on the x-axis, and I would definitely want project L. The way we use this NPV profile then is we say, what is the probability that my discount rate is on whichever side of that crossover rate that I need to be on? And therefore I really need to figure out where my crossover rate is. So the crossover rate's the rate at which both projects have the exact same net present value. If one knows the crossover rate, then one can assess the probability of the discount rate being that low or high and can better rank the priorities of potential projects. The slope of the line, or the approximate slope of the line, you may have noticed that they're not completely straight, in an NPV profile measures the sensitivity of NPV to the discount rate chosen. And at different points it may be very, very steep, in which case it's very, very sensitive, and if it's fairly flat, then it doesn't make any difference, or doesn't make a lot of difference as to what the discount rate is. And just to point out that the two had different slopes. The one with the shorter, in fact let me go back up and show you, the one with the shorter payback is flatter, whereas the one with the longer payback is steeper. That's always true in financial instruments, by the way. So the longer projects are typically much more sensitive to the interest rates than the shorter ones. Let me talk a little bit about things I've been talking about all the way through, and I'm just going to review this as a formal discussion point. When we talk about projects, a set of projects, the projects are either independent, meaning that I can either adopt or not adopt, and my adoption decision with this project has nothing to do with any other project on the table. Those are said to be independent projects, therefore. So this one has nothing to do with anything else, and I can adopt it or not adopt it, and it doesn't affect any of the other ones. So if two projects are independent, then adopting one does not affect the firm's ability to adopt the other. If two projects are independent, all projects with positive net present values and or IRRs and MIRRs greater than the discount rate should be adopted. And any of those criteria will give me the exact same answer. In other words, I will get a positive NPV and an IRR and MIRR that are greater than the discount rates. Now, since we're talking about IRR and MIRR, let me point out one other little piece of information, and that is that MIRR that you calculate will always be between the IRR and the weighted average cost of capital. Always. If NPV is greater than 0 and MIRR is greater than weighted average cost of capital and IRR is greater than the weighted average cost of capital, in fact all three of those will happen together always, then we should adopt as long as the projects are independent. And we could have 28 different projects and the answer would still be adopt them all. All projects with positive NPV add value to the firm, and all projects where MIRR or IRR are greater than the discount rate will bring more return than their cost of capital. Therefore, we should adopt them. However, if there are mutually exclusive projects, if two projects are mutually exclusive, then the firm can only adopt one of the two projects. The term is mutually exclusive. That's why I keep using this. If we're looking to use one parcel of land for this project and that project, and we can't do both on the same parcel of land because there's only so much land, then those two would be mutually exclusive projects. I could either do the one or I could do the other. I can't do them both. In which case we need to look at them differently. So which of the techniques should be used to decide which project to adopt in that instance? The answer is use NPV. It doesn't have the issues that all of the other ones do. It's trying to measure what happens to the value of the firm if we adopt the project. The other ones are just trying to get a % return, which may or may not translate into value of the firm. Depends on how much we're actually investing. Let me do one more technique, and I'm sorry these are split up so much, but this one kind of never does get treated as if it's one of the deciding criteria. It's usually a best supporting actor or actress. So I'm handling it last after we've talked about everything else. It's called profitability index. I don't think that Excel actually calculates this one directly, but it's not that hard to do anyway. So we're going to do it fairly quickly, fairly easily. So profitability index, this measures the benefit per unit cost, so it takes into account the fact that the initial investments may be a little bit different. So it's going to take that into account, and it's based on the time value of money, so it takes the best of both worlds. So a profitability index of 1.1, for instance, implies that for every dollar of investment we create an additional 10 cents in value. So it's really taking a look at net present value, but then it's scaling it for whatever we invested to begin with. I'm hoping that makes some sense. This measure can be very useful in situations where we have limited capital and we need to get a good return on that capital. And here's the way we do this. I'm going to just give you an example. Yes, it's the same example. Deal with it, okay? You've been presented with the following two potential projects. Yeah, you guessed it. Project Gamma and Project Psi. And what we're going to do with these is take the step 1, calculate the present value of all future cash flows, and those are the inflows at today's dollars. If we look at Gamma, it's 1821.45. If we look at Psi, it's 3,643.83. You can actually see fairly easily because of the Gamma, with Gamma, we're investing 100 or 1,500. So as we do the negative 1,500 plus that, you can actually see the 321.45. And with the project psi, when we're looking at present value, we can take the 3,000, which is negative, and add it to that. We'll get the 643.83, which is the net present value. So you can see the inflows, the influx in this case, and their present value. And then if you go, okay, what was the net present value? Add the initial. Oh, okay, that's what it is. But in this instance, instead of looking at those outflows as negatives, we're putting them in the denominator. So divide the present value from step 1 by the initial outlays. Now we're going to take the absolute values of them. So in the first case, we're doing the 1821.45 divided by 1500. Remember that had we left the negative on there, added the two together, we'll just get the 321.45. In this case, we're getting 1.2143. And in the second one, we're getting the 3643.83 divided by 3000, or the 1.2146. Now at this point, I'm going to show you how to do these in Excel. So hang in here just a sec. Okay, at this point we're going to be looking at the profitability index. So I'm going to call this, I hate to call it this, but it's PI, profitability index. Many people will say that's the way you spell pi, and that's 3.1415, etc., 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 and I'm not going to go in there. So we're going to go hit equal, and as we mentioned before, this is the present value of all of the inflows in the numerator. So the easiest way of doing that is the NPV. We're going to look at the rate, and again I'm going to hit my F4 key just so that I can hold that one constant, and then I'm going to highlight from time period 1 through 5. Remember, NPV doesn't even look at period 1 at period 0 at all, but even if it did, we don't want that one in here anyway. So I'm going to close the parenthesis, and in this case I'm going to divide by the absolute value of the times $0, the outflows. I'm going to check really quickly, and I usually do this. Did I put the F4 where I needed to put the F4? And the answer is yes, only on the weighted average cost of capital. And so I'm going to hit enter, and there's my 1.21. I'm going to pull it across once, and there's my 1.2146. These are both 1.21, very close to one another, but this one squeaks out a little bit more than that one. What are the advantages or the disadvantages of profitability index? Well, the advantages are it's closely related to NPV, generally leading to identical decisions, because in this instance, as long as it's greater than 1, we would adopt. It's easy to understand and communicate. It may be useful when available investment funds are limited, so I can see which one actually improves my value given the initial investment. That's the key here. Disadvantages, it may lead to incorrect decisions in comparisons of mutually exclusive investments, because it may say, ooh, that one gives me a high return on my investment, although the other one will actually improve the value of the firm a lot more. Two last components that I need to talk about. The first one is analyzing projects with diverse lifespans. Up to this point, all of our projects have had the exact same useful life or life spans. They've all had 5 years, which was nice. The problem is that in many instances that may or may not be true. And to run these capital budgeting techniques, we need them to have exactly the same lifespan. If they don't, then they tend to bias the results, especially if you need to rank them to decide which one is the best one. In other words, if they're mutually exclusive, we should probably make sure that we've set some things up in a specific way so that we can decide which of the 2 or 3 or more projects is going to add most to the value of the firm. when they don't add up exactly, in other words, if you have two options, one of them has a useful life of one set of years and another one of something different, doesn't even have to be vastly different, it just has to be different, then it can add some bias that one of them is longer than the other. And therefore, how do we make adjustments? There are two ways that our textbook really focuses on. There may be more, but there are two ways that we can take a look at to make adjustments in this instance. The first one is called the equivalent annual annuities method. With this method, what we're going to do is, instead of comparing the net present values themselves, the analyst will take the net present value and say that's how much it's worth right now. And if I invest it right now and use the weighted average cost of capital as the discount rate and the life of the project as the N, I'm going to now solve for PMT. The PMT itself will give me what that is worth, what it would give me as an annuity, which is why it says equivalent annual annuity. Then instead of comparing the NPVs of these two options, we're going to compare the payments, because the one that will give me the higher payment over its useful life is actually giving me a higher return per year, and therefore that's the one I should actually choose. This is actually a really clever way of getting at the best of those options. The other one is a little more difficult. It's called replacement chains. With this one, what you end up doing is repeating the shorter projects, or maybe both or all projects, until we get all of them ending at the same time. So if you have several of these with all different ending dates, oh my word. This is the only way you could run the replacement chain, is finding a common denominator and running them out that far. And the problem that you have in that instance is you may not know how much the replacement costs will be in the future. You can make some assumptions, and in many instances those assumptions have to include the inflation rate. So at that point, once you get them with all exact ending dates, you can actually look at the net present value as we did before. Phew. But that one could be a real pain. So let me show you how both of these work with a simple example. And this one I ran out of creativity with, so I called it the blah blah widget firm. Why? Because I couldn't come up with a good funny sounding name. And widgets, people always use widgets in college, so I decided the blah blah widget firm is probably the name that I'm going to use. It is considering two mutually exclusive solutions. They have to be mutually exclusive, or it doesn't really matter. As long as they have positive net present value, we'll just accept all the ones with positive NPV. But if these are in fact mutually exclusive, then we need them to end at exactly the same time. So the two cash flow streams are estimated in the table below. Assume a weighted average cost of capital of 7.5%. Which project, if any, should be adopted? And I say if any because if they're negative, then the answer is neither of the above. So if it's not, if they both turn out positive, then I'm going to have to figure out whether it's project A or project B. Now notice project A goes for 3 years. Project B goes for 6 years. Yeah, I made sure that they would easily do a replacement chain quickly. And so let me show you how to do these in both ways, the EAA and the replacement chain. And I'm going to do two different replacement chains, one of them a more textbook approach, and the other one let's adjust for some inflation, which we really should be doing, by the way, because inflation rate is embedded in our weighted average cost of capital. Okay, in this instance I already have the numbers preloaded because I don't want to waste our time doing that. And I guess our first step is going to be, let's take a look at the net present value. And again, I'm going to be looking first at the weighted average cost of capital equal to 7.5%. Then I'm going to be looking at what is the EAA. Actually, first off, what is the NPV? Actually, let me go right under that so I'm not wasting lines. I hate it when people waste electrons, don't you? All those electrons have died, and never mind. So NPV is equal to, and we're just going to say NPV, get my rate, and since these are not going to be able, I'm not going to be able to copy across because they have different lives, I'm not going to worry about the F4. Then I'm going to get 1 through 3, close parenthesis, and add my times 0. So that's how I'd get my NPV. And unfortunately for me, it decided to give me a bunch of garbage. And so let me get this back to where I want it. Goofy thing. Oh, I guess I'm going to have to move that out a little bit. So 15, 24, 55. I'm going to say equal net present value. I'm going to get the same rate, comma. This time we're doing 1 through 6 because that's how many they have. Close parenthesis, plus my initial investment. And I'm going to hit enter, and unfortunately did the same stupid thing. And I'm going to then get it to go small again. It has 2012.74 in net present value. Now we wanted to do net present value because EAA uses net present value as an input. So I'm going now to EAA. Guess I should do it right underneath. EAA. And in this instance I will say equals PMT because we want the payment. What's the rate? The interest rate is that one. What is the number of periods? In this case it's 3. In the case of the first one it's 3. What is the present value? In this case I'm investing, so I'm using a negative. The net present value because I want the EAA to be positive, and it is. It's 586.25. Then I do the same thing with EAA for B. I say equals PMT, rate's the same. This time the number of periods is all 6 because we're doing this over 6 periods. The net present value in this instance is the 2012.74. We do negative because we're investing it and we want a positive number out. I close my parentheses and I hit enter. Now note first off that had we used net present value, since these are mutually exclusive, I would have chosen project B. And note that once I take a look at the equivalent annual annuity, my answer goes the other direction and says I should be choosing project A. I'm wondering if I get the same answer if I did a replacement chain. Let's find out by putting in a replacement chain that does not take into account any inflation. I'm going to move over just one here and say this one does not. In fact, what I should do, let me insert a row here and then say no inflation. Ooh, man, I think I put a weird, I think it said inflation. That would be a strange term. I'm not even sure what that means. And so in this instance I'm going to say the cost in times 0 is the same either way. Okay, so far so good. And then I'm going to say the next few are all the same as well, down through 3. And then at time 3 what we're going to do is then say we're needing to set this up because this has got to be times 0 for the next chunk. So I'm going to say plus that one. And we'll just pull those the rest of the way down. Now you'll notice that the ones in B are exactly the same. and that these up here appear to be the same as, these up here, yeah, those up there are the same as these down here. The only differences are those two right there, because we're having to reinvest, and then we get the 1600 out all over again. It's kind of confusing, but yeah, that will work. At this point, we're going to do the NPV, because that's all we have to do with replacement chain. We're just looking, in fact, let me put it down here, replacement chain. Replacement chain. So we're just replacing until we get a termination time which is consistent, which they are in this instance. So I'm going to say is equal to net present value interest rate. This time I do want to hit F4, comma, and I'm going to be doing all of those plus that one. And by the way, you may say that one's a negative. Why are you doing it that way? And the answer is net present value doesn't care. It's just translating into times $0, so it doesn't really make any difference. So I'm going to hit that one. Oh, darn it. I'm just so sick and tired of that. We're just going to change the formatting there. I know I didn't have to do it for that one. And note, even in this instance, so let me highlight these so that we know which ones are saying which. That one is telling me to adopt B, but EAA is telling me to adopt A. No inflation is trying to get me to adopt A. Now let me do inflation. So I'm going to grab the same numbers, copy, I'm going to move over just a couple more, and then I'm going to say, and set this up the same kind of way. I'm trying to remember, I'll try to figure it out I guess as I go along. So I'm going to do that one. And the first ones, there are no inflation. And let me go down to there. In fact, this one can just continue on because we don't ever have to replace it. But we're going to assume that the second time through, everything is going up at a 2% interest rate. So I'm going to say assume 2% inflation across the board. So in this instance, I'm going to get my 1600 out, but I'm going to have to add that to the 2500 times 1.02, that's the 2%, and it's going to be, we're going to allow it to grow 3 times for 1 time 1, 2 time 2, and 3 at time 3. So it's 3 because we're doing the 2500. It then undergoes 2% inflation for year 1, 2, and then 3. That's when we actually have to buy a new one, which we're assuming grows at 1.02 for 3 time periods. I'm hoping that makes some sense. And the way we've set this up, it's going to do this correctly if we just copy it down. So we hit enter and we pull that down, and we get a negative here, but the rest of them are positives. So I'm going to highlight those and copy, because note we have held the rate constant and everything else, it should be okay. I'm going to move it over here and hit enter, and we're hoping that the yellow is correct, and in fact it's even more correct here than it was here. So we're actually making even more money there. So had we just done NPV, we'd have made the wrong decision, the wrong decision, the wrong decision. Okay? In other words, we would have been wrong. Last concept in the chapter that I'm going to cover, I mean there are some others that you should really read. For instance, useful life versus economic life, different lives and how they're defined. That's kind of interesting. But capital rationing is something that is somewhat controversial among academics, because some academics say there shouldn't actually be any capital rationing. There's a different reason why they're not taking into account all of the possible projects out there. The idea is this: theoretically, all projects that add value to the firm, in other words, all those with positive net present values, should be adopted. The total cost of all accepted projects is known as the firm's capital budget. So if you sum them all up and say, here are all the ones we're going to accept, that number is the capital budget for the firm that year. Usually, however, firms don't accept every single one that has positive net present value. And because they don't, theoretically, that's called capital rationing. You're not allowing it to grow as fast as it really wants to. Why is that? So when all such projects are not adopted, the firm is said to be capital rationing its capital. So does that mean that the firms are not attempting to maximize value of the firm and therefore shareholder wealth? Actually, that's not the best explanation. The rational explanations, or the way of rationalizing that according to our textbook, is as follows. First, there's the capital market constraints, real or imagined. In some instances, companies get really reluctant to issue new equity capital because it sends a bad signal to the market, perhaps. The cost is extremely high, and if we're wrong, that could be a little nerve-wracking, because that will increase our weighted average cost of capital and make everything else nasty as well. But in addition to the costing us more money, it also costs me a lot more time, because whenever you issue stock, you have to go through an investment banker, and investment bankers usually, that's going to take a little bit of time. It's almost like dating for a year or two before you actually issue some equity, especially if you're not used to being in the market. That's going to take a lot of time, and because of that, there are some capital market constraints which say I really can't raise it any faster than this, and by the time I raise it, this opportunity may go away. So why even get started? That means it may be rational for the company to have capital rationing. There's also a reluctance on the part of current sources to fund a huge expansion, because they go, okay, once you get to be that big, you're a different company than the one I'm used to, and therefore I'd have to reanalyze this. Again, every time we put extra time in there, that opportunity may go away by the time we actually get the funding in place. And because of that, that may not be an issue of, wow, we're not maximizing our shareholder wealth. It may just be I can't raise that money very quickly. And by the way, add to this that flexibility issue that we talked about early on. And if I am borrowed up to the hilt and can't go out and raise equity funds without doing a huge, long courtship ritual with my investment bankers, then at this point, I'm going to have to forego a whole bunch of things unless I build a little bit of flexibility into my capital budgeting process. In other words, I'm going to leave myself a little room so I can still get a little bit of extra capital if I need it, if a really good project shows up. That's another reason why we may have capital rationing, and it's really capital market driven. The second is there may be some constraints on non-monetary resources. I don't know how I got managerial. I'm thinking in my head instead of actually writing what I'm supposed to be saying. So this should say non-monetary resources. The big constraint here is on human capital. We may have the best people to run so many projects, but you give them too many, and I'm going to run out of people I can actually believe in. This is kind of the internal equivalent of what I just described in the capital market constraints. If I can't get my fingers on enough people that I know will be able to run these projects, I'm going to stop adding more projects because I don't know whether I can get my projects to be successful. And it has to do with non-monetary resources that are constrained. Human capital that I feel confident with. 3, a way to control for estimation bias. This one, managers are certain that different people in the company have set up these capital budgets in a way so that they can build their own little fiefdom. And so they've presented all of these stories about this is going to be the best thing since sliced bread, and here's all the money you're going to make. Has a whole bunch of blue sky in it. And because I've seen so many of these with a lot of blue sky, I know that there's a lot of fluff built into the current set of capital budgets that have been presented. And so I'm going to, instead of cutting just as they cross a net present value of 0, I'm going to make a bigger hurdle for them to jump. By the way, this is another reason why they usually like to use IRR, because the NPV, if it's hugely expensive, I may end up with a little bit more buffer in the dollars of, yeah, see, you did make it. And yet, with percent, it's much harder to do that. Or profitability index may be another one where you're going, ooh, you just got above that 1.25 level, and therefore, yeah, you're going to be okay. Either way, the reason capital budgeting in number 3 works is because I need to adjust for the fluff that people have added to the process. This one is really likely in larger companies. With smaller companies, the person doing the capital budgeting is probably the owner and are not as likely to put lots of fluff in there. The other two are much more likely to be the reasons for that capital rationing. I hope that made some sense, and this is the end of chapter 10.